All right, hi everyone. Hello. Okay, all right. So, yeah, are we? Yeah. So, can Discord hear us? Hopefully, yes. That I don't think I'm muted. First, a few administrative things. So I've now added learning outcomes to the calendar. So the calendar is like if you just go to the lecture calendar, which like the recordings are also here. So the learning outcomes are basically kind of a short summary of what you're supposed to know ideally from the lecture, right? So the kind of exact answer to what was in the lecture is, well, kind of whatever is in the lecture notes and on the YouTube, that's what you need to know. But if you want a shorter summary, so if, for example, you want to ask yourself, okay, like, do I understand what went on? How do I know? Well, one way is you can look at the learning outcomes for the week and say, okay, like, do I know every one of those things? Do I have every one of those skills? There is a limit to how much this can be useful just because we're learning a skill, right? So, like you're learning piano, and like if the learning outcome is like knows how to play whatever, sonata, number, whatever on the piano, well, I mean, maybe you know what that means and maybe you don't if you don't actually know how to play it. Maybe you don't even know what you're getting wrong. So looking at those it has its limit, but in case you find it useful, it's there. Really what you want to do if you want to know, did I understand the lecture completely, is just look at the lecture outline, meaning kind of like the different titles in the lecture notes, and ask yourself, okay, like, could I reproduce whatever the professor said in lecture? Do I understand it? Can I modify it a little bit so that it still works but does something different? Stuff like that. That's what it really means to understand the lecture. But the learning outcomes are also there in case you find them useful. So in general, I was asked the question of how do I study for this course, and I understand that in the first couple of weeks, it's kind of unclear what to do because there's lecture, but, well, you had one lab, but you didn't yet have the second lab. So I promise you that things will get clearer as we go on. So the assignment is going to be posted as soon as the entire class is ready to start on it, just because otherwise it wouldn't be fair to post it ahead of time. But you'd have kind of the project, you'd have labs every week, which would provide a lot of practice. Also, there's going to be the online exercises. As we get closer to the midterm, you might start looking at the old midterms. So technically, they're all already on the website, right? So you can look at them right now if you like. It's just that if you look at them right now, you might kind of freak out a little bit because, of course, we haven't covered most of the material that's on the midterm. The midterm is end of October. We are still in mid-September, and just by the nature of things, there is a period where you need to accelerate a little bit, and we're not there yet. So we're trying to kind of start at a reasonable pace, and then kind of the more you know, the better you can study, the more material you can absorb per day. So most of the midterm, we obviously haven't covered yet. So, okay. So that's that. So for now, like the lab is going to be posted definitely for Wednesday. Like the old lab is already there. You can look at it. I'm going to change it a little bit. But basically the labs and the projects are going to be kind of the backbone around which your studying for this course is happening. In addition to just the lectures, which, they're just lectures. So, okay, all right. So one more thing. I now see that it's actually not quite spelled correctly, but the Discord, I created a new channel because I gave up on the ESC180 lecture, which became kind of another spam channel. But So technical Q&A is the channel on the Discord where you can ask questions during lecture, and I see that Paul is there. You are encouraged to answer questions as well if you know how to answer them. I'm going to look at it occasionally during lecture as well to see what's going on. So that would be kind of the back channel during lecture. So if you want to ask something advanced, please post it in the NerdFace channel. Just like the technical Q&A is supposed to be just the content right now, not advanced content where you're asking about something that you knew about before. The other stuff is just spam. You can look at it or not. It's sometimes entertaining spam, but nevertheless. Okay, all right. So that's it, I think, administratively. So today I want to do two things. So I'm going to talk about multiple assignment, and I'm going to talk about communicating information to and from functions. So multiple assignment. So basically, the basic idea is very simple. So you can assign things like this in Python. So this just means put 42 in X and high in Y and praxis in Z. Okay, so you run it, and now this is like this. I can also, it's just convenient, we'll talk about what's happening conceptually later on, but you can also just say X, Y, Z, and it's going to give you the values of X, Y, Z all together as well, and it's 42 and high in practice. So just kind of as a preview, or if you already have some background, I can tell you that what's going on is a little bit more complicated than what line 3 would suggest, because what's happening is this is actually creating a tuple, and then the tuple is unpacked to the left-hand side. If you don't know what I'm talking about, that's completely fine. We'll talk about it in about a month, but there is like complicated stuff, slightly complicated stuff going on behind the scenes, but basically just multiple assignment means, so one assignment means like X equals 42, so you assign 42 to X, and here you're assigning multiple things to multiple variables at the same time, basically. Technically, you're creating a tuple, blah, 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 but we'll talk about it later. Okay, so one thing that this is useful for is swapping values. So let's say that I have an X and I have a Y. I could assign them using multiple assignments, and I want to put the old value of X into Y and the old value of Y into X. So what I can do with multiple assignment is X comma Y is equal to Y comma X. That does it, right? Because you're putting Y into X and you're putting X into Y. That's what we want. And indeed, if you run this, so Alt Enter to run, so highlight and Alt Enter, and then you ask what's X, Y, it's going to say, well, X is high and Y is 42. So that's what we wanted. Okay. So there's some subtlety in how to accomplish this, because if you just say X is equal to Y and then say Y is equal to X, that's not going to work. Why is that not going to work, anyone? Yeah.
Because once you define X as Y and putting Y equals X is the same Y.
Exactly. So you have, so I'll reset X and Y to 42 and high, and now once I do X equals Y, well, I'm pretty much done with everything because the value 42 is just gone, right? So I've overwritten 42 with high, and now both X and Y are high. Doing Y equals X at this point is just superfluous. Y is already equal to X, not going to change. They're both going to be equal to Y, right? So, or the old Y, I should say. So what can you do? you can create a temporary variable, or a variable that's used for temporary storage, that's going to basically solve the problem of if you say x is equal to y, then you've lost the old value of x. So you can say temp is equal to x, and now you can say x is equal to y, and the situation right now is like this. So x is equal to y still made it the case that x is high and y is high, but the 42 is saved in temp. So since the 42 is saved in temp, you can say, oh, okay, so x is now equal to y, so x has the value it's supposed to have, so now I'll just make y have the value temp, and now it's all good. So now x is high. That was made sure of by line 23. And then y is 42 because of line 24. Make sense? Yeah. Oh, there's no questions. Okay, let me check the Discord. ChatGPT. Okay. Don't trust ChatGPT. It sometimes lies on this subject. Okay. So in this course, I'm gonna ask you now something that's related to this, just in a quick introduction. So a lot of the time when you go and interview for an internship or a job in software development, people are gonna ask you kind of a challenging kind of puzzle. And like, to be honest, like, usually it's not the case that people think on their feet and solve those puzzles. It's sometimes the puzzles are so difficult that it's like impossible to do. On the flip side of it, it's also hard to make up a puzzle. So what happens in practice is there is a set of like around 1,000 puzzles that everyone kind of knows about, and you're supposed to study up before the interview, and then the interviewer, well, they might think they're being original, or they might just go to the puzzle store and buy a puzzle. It's a little bit unfortunate because like it's a silly ritual in a way. Like, you're kind of studying a specific set of puzzles, and everyone pretends that you're doing problem solving, when really what's happening is you're just learning a very finite set of puzzles. But that's the culture, and maybe it kind of makes sense. Like, if you're not willing to like learn the solution to like under 1,000 puzzles, why should you get a job, right? So in that way, it's like maybe an okay way to select candidates. So all of those puzzles, well, not all of them, but about 300 something are in this book called Cracking the Coding Interview, which people recommend, so you can look it up. So I'm gonna give those puzzles to you. Like, don't Google them or don't ask ChatGPT. Like, to be honest, a lot of the time it is Googleable, and ChatGPT probably knows as well, just because there's a finite number of those. I don't think that it makes sense to ask them during job interview, so I don't do that when I interview people, or like when I used to interview people in industry. Like, I don't like asking for those kinds of questions. But I think apart from their role in job interview processes, they're sometimes just fun to think about. So that's how I encourage people to treat those. So we'll discuss the solution next week. And like, don't Google it. If you know the answer, please don't post it on Discord. That's gonna kind of spoil it for everyone else, right? So anyway, the first question is, swap the values of integers x and y without a temporary space and without using a temp variable. So I'm gonna give you a hint, because I think if you just look at it, like, there's no way. But I'm gonna give you a first line of a possible solution is like that. There's other possibilities too. All right. So that's a book. So, okay. Okay. Hi, Ronaldo. Okay. That is Ronaldo, right? I think so, yeah. Well, Cristiano Ronaldo. I think just Ronaldo is a different guy from Brazil. Okay. Okay, all right. So, that's that. So, questions? Anything? Yeah.
On the website, it says that it requires advanced materials to swap the two variables if they allow integers. Which advanced material would that be?
Well, if I told you, what fun would it be? Okay, I'll give you so look up XOR. Okay. Okay, yeah.
What is the temporary space?
Well, it's like something like this, right? So here I said temp equals x, so that requires that I create a new variable named temp and I store x in it, right? So that requires extra space. Make sense? And in fact, so that really is advanced material, but this also requires extra space. If you know about Python, this actually creates a tuple, so it copies all three values somewhere else first. So, okay. So I now want to switch to talking about functions. So to remind you, this is where we got last time. So from now on, I'll try to have the discipline of defining the function in here and then going in the main block and using the functions just in the main block. So whatever is inside the if name equals main is referred to as the main block. Okay, so I'll tell you exactly what this does, the if name equals main, sometime probably next week. In the meantime, there was a question on Piazza about that. So if you want to go, on Piazza, you can look at the link here, which explains everything at length. So also just to remind you, so I added everyone on Piazza, but if you haven't seen it, one, please read the Piazza emails. But I don't know how many, I imagine most people are in Discord. I don't know if everyone is in Discord. So this is the invite that you would use in order to get on the Discord to ask questions during lecture. I also think if you can get a link from one of your friends, if you're not in Discord, which I imagine not literally everyone is, and you don't have to, it has its downsides, but a lot of the communication between EngSci students in practice happens on Discord on the whatever EngSci 2T7 server. I'm sure other secret servers I don't know about. It's probably in your interest to go there and at least look around to see if that's the kind of thing that you want to read. And maybe the answer is no. I can completely understand that, but check it out. And then the course Discord is completely separate. I moderate it. So far, I haven't had to do anything drastic other than delete one message where someone posted a PDF that they shouldn't have for copyright reasons. Which is fine from the person. It's just that I can't keep it as an official person and an employee of the University of Toronto. Yeah. Anyway, join the Discord. Okay. No, that's not the right answer because you're not supposed to use multiple assignments. That's using multiple assignments. Where's the dislike button? Okay, so, sorry. If you just give thumbs up all the time, what's the thumbs up mean, right? So you got to sometimes give negative feedback too. Okay. Okay, all right. So that's a function. So I can use it like this. So remember that if I just say something like square 5, it runs. It just is not going to print anything because this is just like if I say 42 or something, right? So I say 42, Python says, okay, if you say so, but it's not going to print it. You can give it an instruction to print it. That's going to be like this. And you can give it an instruction to print square root of 5, and now it's going to print 25 as well. Yes?
What's the difference between return and print?
Well, so that's a good question. So square here, that's the same as this kind of thing in math notation, right? So it's square of x is x squared. So this is this. And what you're saying here is the value that the function computes is x squared, right? So if in math you say like f of 5, that doesn't magically print anything anywhere, right? So on the other hand, an instruction to print, that's actually an instruction to the computer to output something to the screen. Okay? The return is just basically a way to say equals. Right? So here, like square is square, x is x, equals is return. Yeah. So you don't need it for now. It's just something that they do because you'll need it later. So I just choose to always do that because later on it's going to be useful. You're right. Strictly speaking, you don't need it right now. Okay. So, okay, all right. So that's as far as we got last time. So here's a first kind of complication. So what I'm doing here is I'm writing a function. And this is just a comment. I'll explain it in a second. So this is what's called a doc string. So, and by convention, so it has to be indented, and so usually it has to be a string. By convention, it's in triple quotes. If it's multi-line, it kind of has to be in triple quotes. By convention, it's in the imperative, meaning it's like an instruction to the function. So what do? I say to the function, return whatever, return true if whatever. So not like returns, not the function returns, just by convention people say return. Of course, the program is going to run even without a doc string at all, and whatever you write doesn't matter there for Python. It's just for human readers. That's just the convention. So, okay. So now I can write the actual function. So here's what I'm going to do. I'll compute disk first. And this is not the most elegant way to do it. I'll do a more elegant way in a second. So what I did here is, rather than do something like this, which is the same as, why did I delete it actually? Which is the same as f of x is equal to x squared. What I did is I defined a variable here, right? And it's probably intuitively pretty clear what I'm doing here. I'm just saying, well, I want disk to be b squared minus 4ac, and then if this is greater or equal than 0, then the value is true, otherwise it's false, right? So you can think about disk as a sort of scratch space, right? So if the computation is too complicated, you could just say, okay, like b squared minus 4ac, I just put in disk, and then I'll use disk instead of saying b squared minus 4ac every time. So that's called a local variable. So that's a little bit different from what you see in math. So the other thing that's a little bit different is you have an if-else statement, right? So you can, in fact, write something like, so you might have seen notation like this. So something like this people sometimes write, right? And that means like the absolute value of x is like either minus x or x, depending on whether x is more equal than 0 or is greater than 0. And in a way, this kind of statement is the same thing, right? So it's just a different way of writing this. There is a complication, which is really it's not exactly math because the Python is just executed line by line rather than kind of all at once the way math is. But you can think about it like this for now without losing too much, right? So you could imagine just graphically saying kind of like in math has roots ABC is true if b squared minus 4ac is greater or equal than 0, and false otherwise. Make sense? So that kind of does suggest a more concise way of writing things. Like, why don't I just write it like this? And I could, right? So instead of writing this, I could just say return disk greater or equal than 0. And that's the same thing, right? Because what am I going to return? Well, I'm going to return true if disk is greater or equal than 0. Like if disk is greater or equal to 0, if that's true, I return true. If disk greater or equal than 0 is false, then I return false. So that's the same as the statement below. If someone's asking about this, yes. It's the same, of course, but yeah. Yes? Yeah?
How come when you write true and false in the return,
It becomes
bold?
bold. So that's because true and false are built into Python. So it's not kind of something that I make up, right? So you can't write. So usually, kind of if it's built in, it would display as bold, right? So if you just write something like true, and you try to run it, Python will just say, oh, that seems like a variable name that you haven't defined. So true is a special thing that's actually built into Python. Okay, other questions? All right, what's on the Discord? Okay, friends, technical Q&A, well, technical Q&A, I'll change the name. Technical Q&A is for technical stuff only. The jokes go in the other channel, please. Okay. Yeah, just lose, like, please lose all the memes. It's like we can't, yeah. Okay, all right. So that's like that. And in fact, we could write something even shorter. Just say return b squared minus 4 times a times c. And that would do it. Yeah.
So basically skip writing if statements.
Well, I mean, in this kind of situation, if you have if something true, else false, yes, like, yeah, that's equivalent. Sometimes the if statement is more complicated, so it wouldn't work out. Sometimes it's also kind of, you know, like you try to write a one-liner, and at some point it's just like you're showing off at the expense of being clear, and that's maybe not great. Yeah. Can you specify the return type of the function? So yes, so Python doesn't force you to. So you can give kind of a type kind of thing, a type declaration. We just don't do it currently. But you can look up type declarations, so you'll get a warning if you kind of mess it up. But with kind of, especially with inputs, it makes more sense. Kind of with return types, it's harder because in Python, you could have in principle something like this. Right? And that's allowed. And then you have a return B. And if that's the situation, well, Python will not be able to tell before checking the value of A what type is B. So unlike in other programming languages where all the types are pre-specified, in Python they're inherently unspecified, so sometimes this kind of type checking would just not work. Okay. So that was an aside. You don't need to understand it if you don't want to. So, okay. So what's happening when I do something like print has roots? So x squared minus 2x plus 1, that's x minus 1 squared. So that has the 1 root, 1. So that should print true, and indeed it does. So I'll comment this out, Control R. So highlight, Control R, comments things out. So I print this, and it does print true. So what's going on here? So if I run this, I can say step in. So this is this button, the debug step into. And what that's going to do is it's going to step into the function has roots. So what happened here is the 1 got sent to A, and the minus 2 got sent to B, and the 1 got sent to C. So I can check, for example, the value of B now is minus 2. I can just check all of A and B and C. That's 1 minus 2, 1. And disk is not defined yet. But if I step to the next step, now I'm on line 21. So disk has been defined. So now disk is 0. And now I'm going to return 0 greater or equal than 0, which is true. 0 is greater or equal than 0, specifically equal. So then it'll print true, because this greater or equal than 0 is going to be true. All right. So it's a little bit different from what I wrote here in the sense that it happens line by line. So disk is first not defined, and then it becomes defined once I define it. But it's very close to something like this. If you're familiar with this kind of notation, who has seen this kind of notation actually? No one. Okay, one person. But it's kind of clear what it does, right? So, okay. So that's like that. So local variables are not accessible outside the function. So if I say print disk here, it'll say name disk is not defined. Why is that? Well, disk is a local variable. It exists for the duration of the run of the functions So outside the function, disk is just gone. Again, think of it as scratch space. Are you stretching or do you have a question? Stretching. So okay. So similarly, the parameters A and B and C are also local variables. So if you try to print A over here, that's also not going to work. You'll note here that it just says name A not defined, doesn't say anything about disk, and that's because the first time that Python encounters an error, it just crashes. It doesn't even try to print disk. So like you only see the first error, which makes sense. Like if you have an error, then like the code later on, well, it would be using something that already produced an error, so it probably doesn't make sense anyway. So Python stops at the first error. So those, you might be familiar with those names. So A and B and C are parameters. So the values are sent into the function. So technically, 1, minus 2, and 1 are arguments. So the things that are sent to the functions are arguments. The things that are received by the functions are parameters. So arguments are particular values. Parameters are variables, so like A and B and C. Of course, this could be something like x. If x is defined, that's fine. That's still an argument. Now, a lot of the time, what you'll hear is people will just call everything parameters, and I suppose it's fine, but if you want to be like technically correct, which, as everyone knows, is the best kind of correct, then the thing that you send in is an argument. The thing that the function receives is a parameter. Okay? So parameters are also local variables. So that's why I can use A and B and C in here. Inside the function has roots, but I cannot use it outside, because outside it's like nothing. And it kind of makes sense, right? So you can have a math function that's like f of x is x squared, and like g of y is y squared. First of all, g and f are the same thing. Second of all, just because you said f of 5 in math doesn't mean that you now get to use x. Right? Because x was like an internal thing in f. It wasn't like an actual, it wasn't an actual thing outside the function, and it's the same in Python. So local variables just exist inside the function, and parameters are a type of local variable. So, okay. So that's like that. And that's basically the usual way that you would communicate information from a function, from outside a function to the function, is you would say the 1, for example, is going to get sent to A, and then minus 2 is going to get sent to B, and 1 is going to get sent to C. So that's how you send information to a function. And then the way you receive information from a function is you look at, so this is called the return value. So you look at whatever the function is returning, and the value of this whole thing is just going to be whatever is after the return statement, or the return keyword, right? So this greater or equal than 0. So that's how you get information from the function. So that's the usual thing. Now, sometimes it's a little bit different. So first we're going to do something a little bit different. So we're celebrating International Talk Like a Pirate Day. Today, technically it's September 19th. For people who don't know, so pirates say ahoy instead of hi, and they call people salty dogs, or salty sea dogs rather. Well, depending, if you're good friends, you could just say salty dog. They say yar and stuff like that. So okay, and tomorrow is Talk Like a Pirate Day, so we're celebrating early. Okay. So I'll first write a function that's similar to square in some ways. Right, and I'll do like ahoy, space. So something like this. Okay. So this is kind of like math, except the input is text rather than a number. And the plus, if you remember, so if you just say like hi plus hello, that just sticks them together. If you do a space here, so the way I made sure to make a space, to make spaces after ahoy, then you can have like hi space hello, right? So here I can say whatever, so per ratify string, yeah. So something like this. So if I run it by itself, this just has a value. It doesn't print anything because I never told it to print anything. But if I say print pyratify string, then, well, what's the value of pyratify string? Well, it's ahoy plus I heart praxis plus yar, right? So that's what it prints. So it's the same as math, except instead of manipulating a number, you're manipulating a string there. So you could also have a function whose job it is not to compute some kind of value the way kind of this function works. So either pyratify string or f of x is equal to x squared, but whose job is actually to do something, to, for example, print something to the to the screen. So I'll name it pirate print. And the job here is going to be to print the pyratified version of x. And I could just say print, and then pyratify string x, like this. And now I can just say pirate print, and for example, civ or something, right? And note that here I don't have to say print pirate print. I just say pirate print. It's now its own function. Now inside this function, it calls print on the pyratified version of the input. And you can make it a little bit general. So here it's like not as good as the original print, because if you tell it to print 42, it's going to say it's an error. And that's because ahoy plus 42 plus yar makes no sense. But you can fix it. So you can just say convert x to str. If x is already an str, that's fine. But if it's a number, then we'll convert it to a string first, and then we'll pyratify it. So now pirate print is just almost as good a function as the original print, right? You can just use that instead of print, and everything will be pyratified. It's great. Make sense? So note that there is a subtlety here. This function is different from this kind of thing because its job is not to compute anything. Its job is to do something, to print something to the screen. So a math function doesn't do that. So there is no function f in math that you use and then suddenly something appears on the screen because of that, right? So it's a different kind of thing. It has an effect. It doesn't compute anything as such. So that brings us to the last thing I want to talk about today, which is global variables. So unlike local variables, if you say something like this, x is 42, well, of course, here you can print x, but you can also say inside a function, x is global and I want to print it. This is technically optional in this particular case, but I'll do it regardless. So this will print 42. So that's another way to communicate information to the function is I just set x here. So this x is not defined inside any function, so it's not local, it doesn't go away. And then I say print x, and inside print x I say, oh, like the x I want to print is global. Just print me the global x. And it does. So I didn't have to pass it as a parameter. Sorry, actually here I said it regardless. I meant print x like this, which does the same thing. So I'm not giving it the value of x. It happens to be named print x, but that's just the name. It could be print y as well. It's still going to print x, right? So just making a point here. So that's another way that you can communicate information to a function. And similarly, you can communicate information from a function by saying, I want to change the global variable x, so you have to say global x, and then you say x is equal to 43. So in the second case, in set x to 43, if you haven't set global x, then it would assume that x is local, because by default it's going to be local. So here, you can call the function set x to 43. And you can print x again. And now x is going to be 43. So another way to communicate the information to outside the function, in addition to just using return, which is what you should do, but sometimes you can do something like this. So just set the value of a global variable, and then you can just access it with print x. You could, of course, also just directly say print x. So that will also print 43. So this is the print x from line 33. So if you've done programming before, you were probably told don't use global variables, and that's usually good advice. In general, you shouldn't if you can avoid it. The thing of it is, in Python, for one thing, a lot of the time you create global variables almost by accident. So anything in the main block is global. So you need to know about global variables for that reason. And also, sometimes it's very inconvenient to use the parameters and return values in order to communicate between functions if you need to communicate a lot of information. Now, so this is going to make sense just to people who have background in programming. So if you know about instance variables and things like that in object-oriented programming, then you might, in that kind of case, use instance variables rather than global variables. But really, if you think about instance variables are also global. Any method in the class, if you know about that, can access an instance variable. So in that way, it's just equivalent to a global variable. So we're not doing classes in this course. So for that reason, we're using global variables. Really, kind of, if you think it's bad practice, you also think instance variables are bad practice, and nobody thinks that. So trust me, kind of, when I ask you to use global variables, it's for a good reason. With that said, if I don't ask you to use global variables and nobody explicitly tells you you should probably use a global variable, it's extremely, extremely likely that you shouldn't. But you need to know about them, because otherwise you'll get bugs in Python where you accidentally made the global variable and you wouldn't know why. So that's part of the reason that I'm teaching it now. There's going to be practice about that on Wednesday or Thursday, depending on when your lab is, and I'll see you Wednesday. Thank you. Bye.